Hello friends, myself Rajendra Mahajan presenting my video on one-shot revision of Fourier series all types. Let us try to solve the following. First one, find Fourier series for the function of the function f of x is equals to pi into e raised to kx in between the range 0 less than or equals to x less than or equal to 0 less than x less than 2 pi. It is a problem of full range. Second, f of x is find Fourier series for the function f of x is equal to 1 minus x square in the interval -1 less than or equal to x less than or equals to 1. As it is -1 to 1, we can check it for even or odd. Either it must be even or odd. Third, find Fourier series of f of x is equals to 1 minus x or x plus 1 in the range -1 less than. Third, find Fourier series of f of x is equals to x plus 1 range -1 to 0, and second value is x minus 1 range 0 less than x less than 1, between 0 to 1. Again, it is from -1 to 1. We can check whether it is even or odd. Fourth problem, obtain half range sine series for the function f of x is equal to x minus x square in the interval 0 to 1. And last problem, obtain half range cosine series for the function f of x is equals to 2 minus x. F of x is equal to 2 minus x in the interval 0 less than or equal to x less than or equals to 2. Therefore, total 5 problems I am going to solve. Therefore, watch it up to end for better understanding. First example, f of x is equal to pi into e raised to kx, range 0 to 2 pi. Comparing this range with c to c plus 2l, full range, we get c is equals to 0, c plus 2l is equals to 2 pi. Substituting the value of c as 0, we get 2l equals to 2 pi, means l is equals to pi. And then full range Fourier series is obtained by the formula is like this: f of x is equals to a0 by 2 plus summation of an cos n pi x divided by l, n changes from 1 to infinity, plus summation of bn sine of n pi x by l, n changes from 1 to infinity, and we call this as equation number 1, where the value of a0 is obtained using the formula 1 by l integration from c to c plus 2l f of x dx. Substituting the values, l as pi, therefore 1 by pi integral from 0 to 2 pi, f of x is pi into e raised to kx with respect to x, pi get cancelled, integration of e raised to kx is e raised to kx divided by k, limit from 0 to 2 pi, 1 by k we take outside. Substituting the upper limit, it becomes e raised to 2k pi minus e raised to 0 for the lower limit, and therefore it is 1 by k multiplied by e raised to 2k pi minus 1. Equation number 2. This is the value of a0, first Fourier coefficient. Then we find out an as 1 by l integration from c to c plus 2l f of x multiplied by cos n pi x by l and its integration with respect to x. Then substituting value, we get 1 by pi, lower limit c as 0, upper limit as 2 pi. f of x as pi e raised to kx into cos of n pi x by pi get cancelled, we get cos nx only. And we call this equation number A. And to integrate it, we take the help of this result. We know this result, integration of e raised to ax cos bx dx as e raised to ax divided by a square plus b square a sin b a cos bx plus b sin of bx, a standard result for the integration. Then comparing, we get the value of a as a coefficient of x in the term of e raised to kx as k and b as n. Substituting these values, we get an as e raised to kx whole divided by k square plus n square. A means k cos of nx, b means n sin of nx. Limits for the outer bracket from 0 to 2 pi. Substituting the upper limit, we know the values of this, cos 2 n pi as 1, sin 2 n pi as 0, sin 0 as 0 and cos 0 as 1. These four values for the limits, and then using these values we get an as e raised to 2k pi divided by k square plus n square into k into cos 2 n pi is 1, therefore it is k into 1. Sin 2 n pi is 0, therefore it is 0 minus lower limit, it becomes e raised to 0 divided by k square plus n square into cos 0 as 1, therefore 1 into k plus sin 0 is 0, second term becomes 0. And then from these two terms we can take k upon k square plus n square common. Remaining terms are e raised to 2k pi and minus 1. This is the value of an. We call this as equation number 3. Then similarly we find bn as formula is 1 by L integration from c to c plus 2L f of x sin of n pi x divided by L and its integration with respect to x. 1 by pi integration from 0 to 2 pi fx is pi e raised to kx sin of n x dx. Again pi get cancelled, and here we take the help of this integration from integration of e raised to x sin bx as e raised to x upon a square plus b square a sin bx minus b cos of bx. Here also comparing, we get the value of a as k and b as n, and therefore bn becomes, with the help of this formula, it is e raised to kx k square plus n square multiplied by k sin of nx minus n cos of nx. Again outer limit 0 to 2 pi for the outer bracket. Then substituting the same values, we get e raised to 2k pi upon k square plus n square sin 2n pi is 0, therefore first term becomes 0. Cos 2n pi is 1, therefore minus n into 1 minus, for lower limit it becomes e raised to 0 upon k square plus n square multiplied by sin 0 is 0, cos 0 is 1, therefore minus n into 1. From these two terms I can take 1 upon k square plus n square into n common. Remaining terms are 1 minus e raised to 2k pi, a value of bn, equation number 4th. Then substituting these three values of a0, an, bn in equation 1, we get required Fourier series as f of x is here pi e raised to kx is equals to a0. The value of a0 is 1 by k. Therefore, divided by 2 means 1 by 2k e raised to 2k pi minus 1 plus summation of an from 1 to infinity. The value of an is k upon k square plus n square multiplied by e raised to 2k pi minus 1 multiplied by cos of nx plus summation of bn. The value of bn is, and limit from 1 to infinity, summation from 1 to infinity, n upon k square plus n square multiplied by 1 minus e raised to 2k pi. This is the required into sine of nx, required answer or required Fourier series. Second example, f of x is equal to 1 minus x square in the interval minus 1 less than or equal to x less than or equals to 1. As the interval is minus L to L, we can check the function either for even or odd. For that, we have to replace x by minus x in the given function so that we get f of minus x as f of minus x as 1 minus minus of x whole square. Once again I will repeat, we replace f of x by minus x on both the side of the given function. Therefore, f of minus x is equals to 1 minus minus x whole square nothing but 1 minus x square. It remains the same, and therefore the given function is an even function in the interval minus 1 to plus 1. And as it is an even function, a Fourier series for even function is given by formula is f of x is equals to f of x is equals to a0 by 2 f of x is equals to a0 by 2 plus summation of n changes from 1 to infinity an into cos of n pi x by L, where the value of L is 1, and we call this equation number 1, where a0 is given by formula is two by L. a0 is equals to 2 by L integral from 0 to L integration of f of x with respect to x between limits 0 to L, and then substituting the value of, therefore a0 becomes 2 by L. L is here 1, therefore it is 2 by 1 integration from 0 to 1, and function f of x is 1 minus x square and its integration with respect to x. Integrating each term with respect to x, we get 2 as it is. Integration of 1 is x, integration of x square as x cubed by 3, and limits from 0 to 1. Substituting the upper and lower limit for that two terms, we get 2 into, for the first term it is 1 minus 0, lower limit is 0, 1 minus 1 by 3, and minus lower limit x is 0 for both the term, and therefore it is 3 minus 1, nothing but 2 into 2 by 3. Therefore, it is equals to 4 by 3, value of a0. We call this as equation number 2. Then we obtain the value of an. Formula is 2 by L, integration from 0 to L, f of x multiplied by cos of n pi x divided by L, and its integration with respect to x. Substituting the value of L as 1, integration from 0 to 1, fx is 1 minus x square multiplied by cos of n pi x divided by 1, means it is cos of n pi x, and its integration with respect to x. As it is a product of two terms, we can apply integration by generalized part. 1 minus x square is algebraic term, therefore we consider that as the first term, and cos is a trigonometric term, therefore second term. And therefore applying generalized part, we get the value of an as 2 into first term as it is 1 minus x square, integration of cos is sine n pi x divided by n pi minus derivative of 1 minus x square with respect to x is minus 2x. Next integration of sine is minus cos n pi x divided by n square pi square. Then plus a derivative of minus 2x is minus 2, and integration of cos is sine with that minus sign, therefore minus sine n pi x divided by n cube pi cube, bracket close, outer bracket close, and limits from 0 to 1. We substitute the value of x as 1, upper limit, and lower limit as 0. Therefore, it is 2 into 1 minus 1, that term becomes 0. Then minus minus, 3 times minus minus, 2 into 1 means 2, and cos of n pi, value of cos n pi, we substitute in next step, and divided by n square pi square. Minus minus, it becomes plus, sine of n pi is 0, minus lower limit, sine 0 is 0, first term is 0. As x is 0, second term also becomes 0. And once again sine term, sine 0 is 0, therefore that third term is also 0. And therefore simplifying it further, we get the value of an as minus 4 cos n pi, means minus 1 raised to n, divided by n square pi square. And that is value of an. We call this is equation number 3. And Bn is 0. Then substituting these values in the equation number 1, we get the required Fourier series for that function. F of x is 1 minus x square. The value of a0 is 4 by 3 and divided by 2 plus summation of from 1 to infinity, n equals to 1 to infinity. Value of n is minus 4 into minus 1 raised to n divided by n square pi square multiplied by cos of nx or n pi x as a required Fourier series for that function f of x is equal to 1 minus x square, which is an even function. A required answer or required Fourier series. Or we can simplify it further. 4 by 3 divided by 2 means it is 2 by 3. It is 2 by 3. Constant term we take outside the summation sign. Minus 4 by pi square is constant term. We take outside, and remaining term as summation of minus 1 raised to n into cos of n pi x divided by n square. N changes from 1 to infinity as the required Fourier series. Example number 3rd. Find Fourier series for f of x is equal to x plus 1 and second value is x minus 1. First between minus 1 to 0, second between 0 to 1. And as it is between minus 1 to 1, we can determine whether the function is even or odd. Let first function as f1 of x as x plus 1 and the second function as x minus 1. Once again I will repeat. Let f1 of x as x plus 1 between minus 1 to 0 and second as f2 of x as x minus 1 between 0 to 1. Replacing x by minus x in the first, we get minus x plus 1, and in range also we replace x by minus x, minus 1 less than x, minus x less than 0. Taking minus common from this two term, we get minus of in bracket x minus 1, 0 less than x less than 1. Nothing but minus of f2 of x. And for the second function f2 of x, we replace x by minus x, we get f2 of minus x as minus x minus 1 between 0 less than minus x less than 1 minus of x plus 1 minus 1 less than x less than 0. It is minus of f1 of x, and therefore the function is an odd in the interval minus 1 to plus 1. And as it is an odd, Fourier series for odd function is given by f of x is equals to summation of bn sine n pi x by L. N changes from 1 to infinity, where bn is equals to formula for bn as 2 by L integration from 0 to L f of x into sine of n pi x by L and its integration with respect to x. Here value of L is 1, therefore 2 by 1 integration from 0 to 1, and between that range 0 to 1 function is x minus 1 into sine of n pi x by 1. And as per LIT rule, x minus 1 as it is Algebraic we consider as first, and sine as trigonometric we consider as second function. Therefore, Bn is equals to first term x minus 1, integration of sine as minus cos n pi x whole divided by n pi, then minus derivative of x minus 1 is 1, integration of cos is sine with that minus sign, therefore minus sine n pi x by n square pi square. Next term becomes 0 and the limits from 0 to 1. Therefore, we have the values of cos n pi as minus 1 raised to n, sin n pi as 0, cos 0 as 1 and sin 0 as 0. When we substitute upper limit as 1, we get the value of Bn as 2 multiplied by 1 minus 1, we get that as 0, sin n pi is 0, therefore plus 0, minus, for lower limit it is minus minus plus cos 0 is 1, it is 3 times minus, therefore it becomes minus 1 into 2, sin 0 is 0, and therefore the value is minus 2 and whole divided by n pi 1, we get Fourier series f of x as summation from 1 to infinity. The value of Bn is minus 2 divided by n pi, Fourier series f of x as summation from 1 to infinity. The value of Bn is minus 2 divided by n pi into sine of n pi x, a required Fourier series or required answer. Then example number 5th, find Fourier series of f of x as x minus x square as a half range sine series in the interval 0 to 1. Therefore, here L is 1 and half range Fourier sine series is given by summation from 1 to infinity Bn sin n pi x by L. Bn is given by 2 by L integration from 0 to L f of x multiplied by sin n pi x by L and its integration with respect to Bn is equals to 2 by 1 integral from 0 to 1 fx is x minus x square into sine of n pi x by 1 and its integration with respect to x, integrating it by generalized part by considering x minus x square as first and sine as second term, we get Bn is equals to 2 as it is. First term x minus x square, integration of sine is minus cos n pi x whole divided by n pi, then minus derivative of that first term is 1 minus 2x, integration of cos is sine with that minus sign, minus sine n pi x divided by n square pi square. Next plus derivative of minus 2x is minus 2, integration of sine is minus and that my previous minus it become plus cos n pi x by n cube pi cube. Limit from 0 to 1, therefore Bn is equals to 2 into 1 minus 1 we get 0 minus sine 0 as 0, sin n pi as 0, therefore that term is 0, and cos n pi, therefore it is minus 2 times minus 1 raised to n upon n cube pi cube, bracket close, minus lower limit x 0, therefore that first term is 0, sin 0 is 0 and cos 0 is 1, therefore it is minus 2 upon n cube pi cube. From these two terms we can take minus 2 upon n cube pi cube common, we get 2 into 2 by n cube pi cube in bracket 1 minus minus 1 raised to n, and due to this term we find two different values for even and odd. For even it becomes 0 and for odd it becomes 8 upon n cube pi cube, or replace n by 2n minus 1 in equation 1. and therefore we get a0 0 an 0 x minus x square as summation from 1 to infinity. Value of bn is 8 upon 2n minus 1 cube pi cube into sine of 2n minus 1 times pi x as a required answer. Example number 5th. Find Fourier series for the function f of x is equals to 2 minus x half range cosine series for the interval 0 less than or equal to x less than or equal to 2. Here L is equals to 2, and half range cosine series is given by f of x is equal to a0 by 2 summation of an cos n pi x by L, n changes from 1 to infinity. a0 is equal to 2 by L integral from 0 to L f of x dx. Substituting value of L as 2, we get a0 is equals to 2 by 2 integration from 0 to 2, and f of x is 2 minus x. Its integration with respect to x, 2 to get cancelled, we get integration of 2 as 2x and integration of x as x square by 2, limit from 0 to 2. Substituting the upper and lower limit for the first term, we get 2 minus 0 into 2 minus 1 by 2. For the second term, it is 2 square 4 minus 0, and therefore it is 2 to the 4 minus 4 by 2 means 2. 4 minus 2, we get the value of a0 as 2. An as 2 by L integral from 0 to L f of x into cos n pi x by L with respect to x. Substituting the value, we get 2 by 2 integration from 0 to 2. F of x is 2 minus x into cos of n pi x by 2, integrating it with respect to x by generalized part. First term as 2 minus x, second term as cos, then we get, it is 2 by 2 get cancelled. In the bracket we have first term as 2 minus x, integration of cos as sine n pi x by 2 divided by n pi by 2 minus derivative of 2 minus x is minus 1, integration of sine as minus cos n pi x by 2 divided by n square pi square by 4. Next term is 0. We stop here and limit from 0 to 2. Substituting the values, we get first term is 0 minus 1 raised to n into 4 upon n square pi square minus lower limit, sine 0 is 0 and cos 0 is 1. Therefore, minus 1 into 4 upon n square pi square. 4 by n square pi square common. Remaining terms are 1 minus 1 raised to n. For even it becomes 0, and for odd it becomes 2. 2 for the 8 upon n square pi square. And therefore we replace n by 2n minus 1 while substituting in equation 1, and therefore Fourier series become 2 minus x is equals to a0 as 2 by 2 summation from 1 to infinity. Value of an is 8 upon 2n minus 1 whole square into pi square multiplied by cos of 2n minus 1 into pi x whole divided by 2 as a required half range cosine series. Cosine series are required answer. Please like my video, share it, as well as subscribe to my channel, and to receive the notification please press the bell icon. Thank you.